Hi there, great to see you again on our online course Easy Geosteering. In this course we simplify the key geosteering aspects, breaking them down into easy-to-understand concepts. We are currently in the second part of the course, BHA components, and in the previous video we covered resistivity measurement. And today we will continue with neutron density logging. Let's get started. The third type of logging is density and porosity, and in fact, a single downhole tool performs two different measurements. To carry out these measurements, we use artificial radioactive sources, which include two components, cesium-137 and americium-241 beryllium. The first is a source of gamma radiation, which helps us detect density and record borehole images. The second is a source of fast neutrons, allowing us to measure hydrogen content, which is then recalculated into porosity. Neutron density logging is extremely informative, and it is used for lithological differentiation, saturation, and permeability calculations. How does it work? While BHA Makeup MLWD engineer loads the sources into the tool, and the proper execution of this procedure critically affects the log's quality. This type of measurements has the smallest depth of investigation, only a few centimeters, so it is crucial to minimize the gap between the tool and the wellbore surface, especially for density measurements. For this reason, the tool often includes a stabilizer where windows are positioned for the gamma ray source and its detectors. So, while drilling cesium emits gamma rays into the formation, allowing them to interact with it. By analyzing the number and energy levels of gamma rays that return to the detectors, we can estimate the formation's density. In turn, americium beryllium emits fast neutrons, which also interact with the formation. Due to their nature, neutrons primarily interact with hydrogen in pore spaces. During these interactions, fast neutrons lose energy, slow down, and become thermal neutrons. These particles can be captured and counted by the helium neutron detectors. By analyzing the number of thermal neutrons, we can estimate the formation's porosity. Before we proceed with readings in common formations, let's consider compatible scales, an important and unique aspect of neutron density log interpretation. For gamma ray and resistivity logging, there are no strict rules regarding scale selection, but for neutron density we should use a specific scale. When drilling in a sandstone formation, we typically set the left scale for density at 1.65 and the right scale at 2.65. And now, pay attention, porosity uses an inverse scale, with 60 on the left side and 0 on the right. Why is it so? It is done for convenient visualization. The point is, if we drill in a clean and non-shell formation filled with water, with density of 1 gram per cubic centimeter, the density log and porosity log will plot on the same part of the track and overlap with each other. If we encounter gas in the formation, we will observe curve separation or gas crossover. The density log will go down on the track, while the porosity log goes up. The root cause is that gas has lower density and lower hydrogen content per unit volume than water. If we encounter a shale formation, we will observe an inverse crossover. The density log will go up while the porosity log goes down, since shale has high density and high porosity. So, this is compatible scales for sandstone formations, but for other formations there are different scales. For example, for limestone you should use the following. For density from 1.95 to 2.95, and for porosity from 45 to -15. Negative values have no physical meaning, just remember this is done for convenient and quick log interpretation. Okay, let's set neutron density to gamma ray and resistivity on our log to form triple combo in real time. Here we have reference value for density. Greater than 2.3 gram per cubic centimeter indicates non-reservoir, while density lower than 2.3 suggests pay zone. There is no reference value for porosity here, but in some projects you might encounter one. So, in the first formation we observe shale effect, high density and high porosity. And as we already know, shale has low resistivity and high gamma ray. In the second formation we observe gas effect and inverse crossover, low density and low porosity. This interval has the highest resistivity and low gamma ray. In formations 3 and 4, the neutron density readings are the same and the curves overlap. This indicates that formation 3 is a clean non-shale reservoir filled with oil, and this oil has a relatively high density, close to that of water. Using the neutron density log, we cannot detect the water-oil contact, meaning that resistivity is the only one reliable method for this. Meanwhile, detecting the gas-oil contact using resistivity is not always possible, because gas and oil within the same formation can sometimes have similar resistivity values, but neutron density log can usually detect it with high accuracy. As we can see, different types of logging complement each other, which is why the Triple Combo service provides highly informative data. And here we need to make some important note. Of course, in nature there are enormous quantity of different formations and geological conditions. For example, sometimes it's impossible to detect gas-oil contact even if we have Triple Combo in real time. Sometimes we encounter argillite which has low gamma ray level like sandstone. Sometimes we have shale with high resistivity, and so on. That's why it's critically important to familiarize yourself with regional geology and find out how specific formation types appear on offset well logs. Okay, let's return to hard layers and coals. Now we can clearly differentiate them. So, carbonate sandstone has high density and low porosity. Both curves go up on the track. Coal has low density and high porosity. Curves go down. However, like shale, coal cannot serve as a reservoir due to its low permeability, despite the fact that these formations have high porosity. Alright, we have covered the neutron density logging. Hope you like this video. Remember, you can boost your practical skills with the private lessons. Together we will work in StarSteer to apply all modern geosteering tools and drilling simulators to provide you an immersive experience of a real geosteering engineer. So stay tuned and give this video a thumbs up. In the next lesson we will explore sensors blind zone and most common BHA types. See you then. Bye bye.